Good morning. Good morning to everyone. Okay. So in the last class we were discussing about some of the questions, right? Before that I had given important concepts related to periodic classification of elements, right? Okay. So in that case, today we will further solve the questions. Fine. So I think less students are there. Yeah, it's time. Okay, what I will do is I will start with the next question. Fine. So next one is fifth question. That is which was asked in Comed K. Earlier it was there, right? This exam, Comed K. So that is atomic numbers of vanadium, chromium, nickel and iron. Okay. So atomic numbers of vanadium, chromium, nickel and iron are 23, 24, 28 and 26 respectively. Fine. So that's what the information. Okay. So atomic numbers of vanadium, chromium, nickel and iron are 23, 24, 28 and 26 respectively. Which one of this? Which one of these is expected to have the highest second ionization enthalpy? Okay, so this is the question. Right? Now, naturally option should be those elements only. A is chromium, B is vanadium, C is iron and D is nickel. Okay. So can you solve it off? So they have given the atomic numbers of these four elements, which are those vanadium, chromium, nickel and iron. Right? So now they are asking which one of these is expected to have second ionization enthalpy, not first one. Second ionization enthalpy, that means second electron, removing of second electron. Okay? So can any one of you can write? Okay, so option C. So that is iron. Okay. Any other answer? Option C. Fine. Okay. So if that is the case, you people are given option C as the answer. We will see. Now, what is the atomic number for vanadium? That is 23, right? So, in that case, I can take the help of argon, right? So, it will be 3d3 4s2. 3d3 4s2. So, that is for vanadium. Now, when it comes to chromium, it is 24. So, here it is also, we can take the help of argon only. All of them, they are fourth period. So chromium, argon. So that is 3d5 4s1. 3d5 4s1. Then we will come to Next one. 1 minute. Okay. So we will come to next one. That is, so next one is nickel. So nickel, what is the atomic number? Atomic number is 28, right? So once again we can take the help of argon. Once again we can take the help of argon. So that means it will be 3d8 4s2. Fine, 3d8 4s2. Then comes the iron. So atomic number is 26. They have given the information, right? So iron, that is 26. Now when it comes to iron, it will be argon 3d6 4s2. 3d6 4s2. So like that, first we have to write the electronic configuration. Fine. So first we have to write the electronic configuration for these elements. So first we have to write the electronic configuration for these elements. Now can you tell me, they are asking which one of these is expected to have highest second ionization enthalpy. So to answer this question, first thing you should know the electronic configuration, right? Anyway, they have given the atomic number, but still my suggestion here is up to 40, at least up to 40, you should be practicing the atomic number with element. If they have not given the atomic number also, you should be able to write the electronic configuration, right? But here they have given the atomic number. So this is where we have the electronic configuration. Now, second ionization enthalpy means what? What is meant by ionization enthalpy? Amount of energy is required to remove the electron, right? So first ionization enthalpy means first electron. Second ionization enthalpy means second electron. Now can you tell me, I have written the electronic configuration. Can you tell me where it will be difficult to remove the second electron? In which element? Some of you, one of you have written option C as the answer. Okay, some of you have written A as the answer. Really, do you think option C as the answer? Because if I remove the electron, it will become Fe plus 2, that is ferrous, 3d6 4s0. Right? But when I am talking about option A, that is chromium, that's where if I remove the electron, second electron from here, then it will become 3d4. It will become 3d4. That means half filled d subshell it is there in chromium. When you remove the first electron, it will become 4s0. Right? Now second electron I am removing. So that means it will become 3d4. Now all of us we know removing the second electron from chromium will be a bit difficult because 3d5 is there, which is half filled. Now we are making it to 3d4. So naturally, appropriate answer should be option A, where high amount of energy will be required to remove the second electron. We are not talking about first electron. Please remember, it's mentioned here, second ionization enthalpy. We are not at all dealing with the first electron. We are talking about second electron. No other way we have the stable electronic configuration except chromium. So therefore removal of second electron will be difficult because we are converting that one into 3d4. Fine. So which should be the answer? Option A. Chromium will be requiring highest second ionization enthalpy. Now if I take iron, this is not related to this question. If I take the iron, removal of another electron, that means third ionization enthalpy will be easy. Why? Because from 3d6 it is becoming 3d5. So it is attaining stable electronic configuration, that is Fe plus 3. So that is ferric. So sorry. So I was talking about iron, right? So that's where it will get converted into Fe plus 3. So it will attain the stability 3d5. So Fe plus 3 is a stable ion. Fine. So but this is not related to this question. So which should be the answer? Option A should be the answer. That is chromium. Fine. All of you have understood? So for this type of question, what is required? For this type of question, major requirement is you should write the electronic configuration. You should write the electronic configuration. Then only you can answer the question. So to write the electronic configuration, what is required? Atomic number. You should know the atomic number. So normally they will give the atomic number, but sometimes if they have not given the atomic number, still you should be in a position to write the electronic configuration. So to write the electronic configuration, what and all is required? Inert gas. So which inert element will be coming to next one? That one you should know. Then you should know about the Aufbau diagram. Fine. So all of you have understood. We'll move to the next one. So that is sixth question. If anyone, if you are not understanding my handwriting, you should ask. Okay. So that's where next question is the correct arrangement. The correct arrangement. Correct arrangement for the ions. Correct arrangement for the ions in the increasing order. In the increasing order. Increasing order of their radii. Of their radii is. Okay, this question was asked in CT. Okay, so what is that? The correct arrangement for the ions in the increasing order of their radii is. Now I will give the option. So Na plus, first one is Na plus, Cl minus and calcium plus 2. Now option B. So calcium plus 2, K plus sulfide. S minus 2 is nothing but sulfide. SULPHIDE. So C. Na plus, aluminium 3 plus, beryllium plus 2. This is 3 plus, beryllium plus 2. And option D. Chloride, fluoride and S minus 2. And S minus 2. Fine. So that's where it is arranged. Elements have been arranged like this. Now you should select increasing order of their ionic radii. Increasing order of their ionic radii. Fine. First. Okay, I will give a hint. Whenever this type of question is there, first find out whether they are isoelectronic species. Whether they are isoelectronic species. Someone has written some answer. So option B. Okay. We will see. So first we should see whether they are isoelectronic species. Fine. Now some of you have written. If I go with option A. If I go with the option A. So the total number of electron, because calcium atomic number is 20. So here it is plus 2, 18. So 18. But here Na plus, that is nothing but 10. Because number of electron in sodium is 11. But here it has been given as Na plus 10. So it is not isoelectronic species. We should be a bit fast. I am explaining it slowly. Now we will come to here. So calcium plus 2, 18. Potassium 19. Here it is K plus 18. Sulfur 16. -2, that means 18. Okay, I have got the isoelectronic species. I have got the isoelectronic species. Darshan, you have written C. I think B should be the answer. So C, we will see. Now when it comes to sodium, sodium is 10. Aluminium 13 plus 3 it is that 10. So then beryllium, no, beryllium is atomic number is 4. That means 4 electron. But here it is plus 2. So therefore 2 electron. They are not isoelectronic species. Fine. So I can see the isoelectronic species over here. Option B. Now if that is the case, always we know that in an isoelectronic species, as the positive charge increases, as the positive charge increases, ionic radii is going to decrease, right? As there is an increase in the positive charge, ionic radii is going to decrease. As there is an increase in the negative charge, ionic radii is going to increase. So that's what we can see. Naturally, answer should be option B, where calcium plus 2 will be of smaller area compared to K plus, which will be of smaller area compared to sulfide. All of you have understood? Any doubt? Any doubt in this? So in that case, shall I remove this one? Okay. So first try to select the isoelectronic species. Okay. Now another type of question. I will modify this question. It's not asked here, but I will ask. So that question can be same question or same concept. I will ask in another way. What is the number of electron in the following isoelectronic species? What is the number of electron in the following isoelectronic species? So there is two work for you. First thing, you have to select isoelectronic species. You should find out which is that isoelectronic species. So then you should find out what is that number of electrons. Now why I am telling this one, because when you want to find out the isoelectronic species, you should know atomic number. You should know the atomic number. So once again I am telling, at least up to 40 elements, practice with their atomic numbers. It will be very much helpful for you. Okay? So we will move to the next question. That is 7th question. We will move to the 7th question. Which of the following is second most electronegative element? Second most electronegative element. Okay. Now option A, chlorine. Option B, oxygen. Option C, sulfur. And option D, fluoride. Right? What is that question? Which of the following is second most electronegative element? Right? So option A is chlorine, option B is oxygen, option C is sulfur, and option D is fluorine. It was asked in an entrance exam related to other state. Okay na? So can you tell me, as I told, I have included JE questions, then I have included CET question of Karnataka and NEET questions, along with that some other competitive exam questions. Mansi, she has written option B. Yes, it should be option B. Because all of us we know, according to Pauling scale, fluorine has the value of 4, oxygen is having the value of 3.5, and chlorine is having the value of 3. Sulfur and all will not come near to it at all. It will be less for sulfur, right? So that's where I can see first electronegative, second electronegative, third electronegative. But here they have asked second most electronegative, so therefore option B, that is oxygen, should be the answer. Fine. So for seventh question, which is the answer? Option B. Okay. So what do you mean by electronegative? Electronegativity means it is the ability of an element to attract the shared electron. It is the ability of an element to attract the shared electron. What do you mean by shared electron? That means we are talking about covalent bond, which you are going to discuss in chemical bonding topic. Fine. So in that case, we will move to the next one. So that is question number 8. Which of the following, question number 8, which of the following does not reflect, which of the following does not reflect the periodicity of the elements? The periodicity of the elements. Okay, na? So periodicity of the elements. Which of the following does not reflect the periodicity of the elements? Now, option, that is option A, bonding behavior. Option A is bonding behavior. Then option B, electronegativity. Option B, electronegativity. Option C, ionization potential. Option C, ionization potential. And the last option, that is option D, neutron proton ratio. Neutron proton ratio. Can anyone tell? So which of the following does not reflect the periodicity of the elements? One is bonding behavior. Bonding behavior in the sense which type of bonding it can make, whether ionic bond, metallic bond or covalent bond. So that is bonding behavior. Then electronegativity. Electronegativity in the sense, as we have discussed in previous question, that means ability of element to attract the electron, that is shared electron. Then ionization potential, that is ability of element to remove the electron, amount of energy required to remove the electron, that is ionization potential. And neutron proton ratio, right? Okay, except Maulya, I think all of you have written option D, right? Yes. Now, when it comes to bonding behavior, it is a periodicity. It is related to periodic property of the element. As I told, group 1 element, if it is interacting with group 17 element, it will go for ionic bond. If any element within the P block, they are going to form a covalent bond. They are going to form the covalent bond. If there is an interaction between electronegative element with other element, then they can show dipole moment in their bonding, in their covalent bond. Anyway, in detail we will not going to discuss. We are going to discuss this one in your chemical bonding topic. So bonding behavior, yes, it is related to periodicity. Okay. So periodicity of the element in the periodic table. Now electronegativity, that is of course all of us we know. Now when it comes to ionization potential, definitely non-metals will be having higher ionization potential or ionization energy. They require higher ionization energy, right? So when it comes to neutron-proton ratio, that's where we are not going to observe. Periodicity is not there. But where this neutron-proton ratio we are going to worry. I had given a 1 or 2 sentence explanation on this while teaching the periodic classification of elements. Can any one of you try it out? What is that neutron-proton ratio? Where we are going to discuss all these things. Which type of element? When we are discussing which type of element, we are going to focus on neutron-proton ratio. I had told 1 or 2 sentences on this and definitely not in detail. So naturally option D should be the answer. Now neutron-proton ratio. Okay, Mansi, very good. So it is related to radioactivity. Right? If I am right, when I was talking about actinoid series, when I was telling all of them, they are radioactive element. During that time I told why radioactivity is present. And one of the reasons that one is difference in neutron-proton ratio. If neutron-proton ratio, if it is unity, so what I mean to tell here is neutron-proton ratio is equal to 1. If it is equal to 1, or you can write like this also, if it is equal to 1, unity, then normally they will not be radioactive. They cannot be radioactive. When the answer is not 1, then those elements will try to attain to that particular 1, unity. So due to that, they will emit the radiation during that particular process in attaining the neutron-proton ratio as unity. Okay? So that's why radioactivity observed where this NP ratio, that is neutron-proton ratio, is far from the unit value, that is unity. Fine? All of you have understood? So that's where we have the neutron-proton ratio. But in periodicity, it will not come. Okay? In periodicity, it will not going to come. This particular ratio. Fine? So shall we move to the next question? Question number 9. I think similar question was there. The correct order of ionization energy. Correct order of ionization energy of carbon, nitrogen, oxygen and fluorine is. CET question. It is a CET question. Karnataka CET. Option A, fluorine less than nitrogen, less than carbon, less than oxygen. So option B, carbon less than nitrogen, less than oxygen, less than fluorine. Option C, carbon less than oxygen, less than nitrogen, less than fluorine. And option D, fluorine less than oxygen, less than nitrogen, less than carbon. Can any one of you, the correct order of ionization energy of? Option C, Maulia. Okay. So according to Maulia, option C should be the answer. We will see. Now, all of them belongs to period number. All of them, they belongs to, okay, all of you are writing option C. All of them, they belongs to period number 2. Right? Now, all of us, we know that fluorine is the last element other than the inert gas. We are not talking about inert gas. So before that, fluorine will be the one which will be the last element in period number 2. Naturally, it requires higher ionization energy. It is wrong. Option A is absolutely wrong. Now we'll come to next one. Here we have carbon, nitrogen, oxygen and fluorine. Now if you observe here, carbon, it belongs to group number 40. It belongs to group 40. Nitrogen belongs to group 15. Oxygen belongs to group 60. And fluorine belongs to group 70. Right? Fluorine belongs to group 70. So in that case, whether it should be the one, right? Or will come to here. So where it is group 14. So here it is group 16. And once again here it is group 15. And here it is group 17. Now, if I look based on the periodic table, Ashish and Darshan, I'll come to that. So if I see the periodic table, I can see this is where group 14, group 15, group 16, group 17. Which looks like as there is a decrease in the atomic size, ionization energy should be increased. So don't be hurried. Okay? Now, one point you people are forgetting, whoever is writing option B, one point you people are forgetting, that is stable electronic configuration. Why I am writing option B? Because many students will do the mistake. Okay? So actually the answer should be option C only, not option B. Whoever has written option B as the answer, yes, they are absolutely right. Now, Achyuta, I think Achyuta or someone had written something about nitrogen. Yes, if I see the nitrogen, so nitrogen, although it belongs to group 50, oxygen, although it belongs to group 60, due to the stable electronic configuration for group 15 elements, they will be having higher ionization energy or enthalpy. There will be higher ionization enthalpy due to the half-filled electronic configuration, stable electronic configuration. Therefore, group 15 should come this side and group 16 should come this side. Although atomic size is for group 16 is smaller than that of the group 15. But still, nitrogen family, that is group 15, will have higher ionization enthalpy compared to group 16, respective group 16 element. Ashish and some of you have written option B. Now you got the answer. So don't do that mistake. Okay. So purposefully I came to option B due to that only. Okay. So many students, they will calculate like this. Group, to which group it belongs to, it is absolutely fine. But ionization energy, there is a slightly variation. Right. So try to remember these informations. Okay. So that's where we have the option C. For this question, option C should be the answer. So we'll move to the next one. Next one is, it was related to JEE questions. So question number 10. Question number 10. Which of the following statement is not correct? Which of the following statement is not correct for the element? Having electronic configuration, having electronic configuration 1s2, 2s2, 2p6, then 3s1. Okay. Now option is option A, monovalent. Option A, monovalent electropositive. monovalent electropositive. Option B, forms basic oxide. Forms basic oxide. Option C, non-metal. Option C, non-metal. And option D, has low electron affinity. Has low electron affinity. Anyone? Okay, Mansi, already she has given the answer as, okay, earlier question, or for this question people have given the answer? For this question only, right? So many of you have written option C, a non-metal. Fine. All of you will agree with that? Okay. Yes, Achyuta. Fine. Yes, all of you are correct. Actually, option C should be the answer because it's not correct for this particular electronic configuration. Now all of us we know that whatever they have written electronic configuration, that is for sodium. Whatever electronic configuration was it is written, it is given for sodium, right? So atomic number is 11, 6 to 8 plus 2, 10 plus 1, 11. So that means we are talking about sodium. And as Achyuta has written, sodium should be alkali metal. It is a metal, but option C has given as non-metal. Fine? Okay. Option C is the answer. Now, monovalent electropositive. Right? So what do you mean by that? That is, when I am talking about sodium, it will become Na plus by donating one electron because it is an electropositive element. So therefore it is called as monovalent. Since it is group 1, so it should have one valence electron. So therefore it is a monovalent. Fine, that is one thing. Option A, that is absolutely fine. Then option D, low electron affinity because it is a electropositive element. It is a electropositive element related to this only. So has a low electron affinity. Now comes option B. So that means forms basic oxide. So here I want to give some information. Okay. So now when it comes to basic oxide, always remember that when we are talking about oxides, what do you mean by oxide? It is the compound of oxygen. Oxides are nothing but compounds of oxygen. Okay, compounds of oxygen, where oxygen will have -2 oxidation state. Where oxygen will have -2 oxidation state. Anyway, in detail you are going to discuss this one in your redox reaction. But here, since they have written basic oxide, it's bit important. So therefore, it will form compounds of oxygen where it will be having -2 oxidation state. They are called as oxides. Fine. Now, whenever we are talking about metal oxide, oxides can be metal oxide, non-metal oxide or metalloid oxide. Okay. So metal oxide, or it can be metalloid oxide, or it can be non-metal oxide. Okay. So oxides can be of 3 types depending on the another partner. One partner is constant, that is oxygen. Right? So yes, Mansi. So that's where we have the metal oxides which are basic in nature. And metalloid oxides normally it will be amphoteric in nature. And it will be acidic in nature. Simple example I will take. See, metal oxide, just now we have written sodium oxide. So sodium oxide is nothing but Na2O because oxygen is -2. One sodium will have the +1. So to make it neutral, how many sodium is required? 2 sodium is required because 1 sodium is plus 1. So therefore Na2O, sodium oxide. Now if I treat the sodium oxide with water, it can easily form sodium hydroxide. Yes, Gahan, you are absolutely right. So sodium oxide can easily form sodium hydroxide. Okay, so that's where sodium hydroxide is a alkali. It's a basic. It forms a basic solution. So therefore metal oxides are considered as basic oxide. This is one of the reasons. Now someone of you have written aluminium oxide. Aluminium belongs to group 30. Aluminium belongs to group 30. So 3 valence electron. 3 valence electron, right? So therefore, when I am talking about aluminium oxide, I have not written the formula. Aluminium oxide, oxygen is -2. Aluminium can attain +3. Aluminium can attain the +3. So what should be the formula? So cross multiply. 3 should go here, 2 should come here. Al2O3. So therefore we have the aluminium oxide, Al2O3. Very good. Right? Now this is an example for amphoteric oxide because it can react with the bases also, it can react with the acid also. Therefore, aluminium oxide is the best example for amphoteric oxide. Fine? So now when it comes to acidic oxide, that is non-metal oxide, I will take a simple example. For biology students, we will be studying this one, that is carbon dioxide, CO2, right? So during respiration, we are inhaling oxygen and we are releasing carbon dioxide. So what will happen if carbon dioxide level will increase in the blood? It will cause the acidic condition. So therefore carbon dioxide is not good, right? Now it is COVID. All of you will wear the mask, right? But when we are alone, when you are walking on a street, no need to cover the nose by your mask, only mouth. Whenever it is required, whenever you will come across someone, you should lift the mask. You should close the nose. That is because carbon dioxide will shoot up if you wear the mask continuously. Fine? So now what will happen? Carbon dioxide can be with water, it can become H2CO3, carbonic acid. H2CO3, and in our blood it can be present as H plus SCO3 minus bicarbonate. Blood 7.2 pH, right? So it will become bicarbonate, SCO3 minus. So that's where there is a release of H plus. Some of you had written about sulfur oxide. Yes, it is also an acidic oxide. They can form sulfuric acid H2SO4 with water. They can form H2SO4, sulfur trioxide SO3 if I take. It can react with water to form sulfuric acid. Right? So that's where we have the non-metal oxide as acidic oxide, metalloid oxide as amphoteric, and metal oxide as basic oxide. All of you have understood? Yes, carbonic acid is a weak acid, no doubt. It is a weak acid. But if the amount will get increased, then it will cause the problem. It can change the pH of the blood. It can make the acidemia condition. Fine? So that's where we have the oxides of sodium. Naturally, it should be a basic oxide. So for this question, which was the answer? Option C was the answer because it was not applicable for sodium, where it was given as option C was having non-metal character. No, that is not applicable for sodium. All of you have understood? So I am giving extra information which is not applicable for this question, but it may be helpful for your other questions also. Okay? So because we don't know which question they can ask in your competitive exam. Board exam we can tell to some extent. Now, question number 11. Question number 11. Okay. So if an atom has electronic configuration, if an atom has electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 3d3, 4s2 will be placed in option A, second group, option A, second group, option B, third group, option C, fifth group, option C, fifth group, and option D, sixth group. Option D, sixth group. Can anyone tell? Can anyone? It's easy. Okay. In an atom has electronic configuration. This is what they have given. Will be placed in which particular group? Don't see other electrons. Focus on outer shell electron or outer electrons. Yes, Shri Vidya, very good. So option C should be the answer because I am not worried about up to here because it's an inert gas configuration, right? So it is an inert gas. That means they are talking about argon, right? Now 3d3, 4s2, naturally it belongs to D block element, transition metals. That means second group it should not belongs to because second group is alkaline earth metal. So one is this one discarded. Option A is discarded because I am not. Answer is option C, no doubt. Now third group. When it comes to third group, it is the first group in the transition metal where you should be having 3d1. Naturally, here it is 3d3. So 3d2 means fourth group. So here it should be fifth group because we have the 3d3. Forget about 4s2. We have the 3d3. So therefore, option C should be the answer. Option C should be the answer. All of you will agree? So that is because of the 3d3 which is present. So option C should be the answer. All of you have understood? Okay. So shall I move to the next one? Okay. We'll move to the next question. Question number 12. Question number 12. All the S block element, it is a JE question. All the S block elements of the periodic table, all the S block elements of the periodic table are placed in, all the S block elements of the periodic table are placed in the groups. Now the option is first A and 2A. Option B, third A and fourth A. Option C, B subgroups, and option D, fifth A and fifth A to 7A. Okay? All of you have seen the question. That's where all the S block elements of the periodic table are placed in the groups. Option A is first A and 2A. Option B, third A and fourth A. Option C, B subgroups. And option D, fifth A and to seventh A. Fine. Now when I am talking about this, it is related to old type of periodic table groups. Old type. Okay. And since they are talking about S block, all of you are right. So option A should be the answer. Option A should be the answer, because when we are talking about group, now we know it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 and 18. So we have up to 18 groups. Regular numbers we have given. But earlier one, it used to be given as first A, second A, third A, fourth A, fifth A, sixth A, then seventh A, then these three they used to keep it as 8, then first B, second B, third B, fourth B, and fifth B, sixth B, and seventh B. This is 0. So therefore they will call it as 0th group according to old nomenclature, old style. In your textbook also they have given both the ways. Okay? So that's where we have the number. If I observe 3A and 4A, so 3A and 4A where transition metals will come. Where 3 and 4, group 3 and 4, that is transition metals will come. Now B subgroup, it is related to other metals other than the alkali and alkaline earth metals. That will be considered as B subgroup metals. Okay. Now 5th A to 7th A. 5th A to 7th A means here we are talking about 5, 6, 7. Once again transition metals. But S block, it is group 1 and group 2. That is 1A and 2A. Fine. So therefore option A should be the answer for this particular question. All of you have understood? Fine. So this old type of numbering, this one Roman numbering, it is there in your periodic table in textbook, NCERT book also they have given. Okay, have a look on that. Now we will come to question number 30. We will come to question number 30. That is generally, question number 30, generally the first ionization energy, generally the first ionization energy, increases along the period. Increases along the period. But there are exceptions. It is also a CET question. It is a CET question. But there are exceptions. The one which is not an exception is, okay? So option A, sodium and magnesium. Option B, beryllium and boron. Option C, nitrogen and oxygen. And option D, magnesium and aluminium. Generally, the first ionization energy increases along the period. All of us we know that. But there are exceptions. The one which is not an exception is, okay, sodium and magnesium. All of you will agree, sodium and magnesium, yes, they are not the exceptions. That is because when I am talking about beryllium and boron, we have already discussed. Outermost electron from S subshell, outermost electron from P subshell in case of the boron. Now nitrogen, it is having half filled stable electronic configuration, right? Exception is that. So same thing, magnesium and aluminium same as that of the beryllium and boron. Here also we have the S and P subshell in the outermost shell. For example, if I take beryllium, what is the atomic number of beryllium? Beryllium is 4. So naturally it should be having helium 2s2, right? So that's where, but boron is 5. So it will be having helium 2s2 2p1. So that's what? P subshell and S subshell. Same logic, magnesium 12, right? Neighbor of sodium. So it will be neon. Neon 3s2. Neon 3s2, right? Now when it comes to aluminium, atomic number is 30. So naturally it should be neon 3s2 3p1. 3s2 3p1. That's where we have the P subshell. Right? Boron family. Aluminium belongs to boron family. So therefore this is not the exception. This is not the exception. Sodium is the first group element. Magnesium is the second group element. Naturally, magnesium will be having or requiring higher ionization energy. Fine. So therefore, option A should be the answer because they have given which is not exception or which does not have the exception. So the answer should be option A. All of you have understood? Any doubts in this question? Okay. So now we will move to the next one. It is JE question. Which one of the following has the lowest ionization energy? Okay. So next one is, which one of the following has the lowest ionization energy? Okay. Now option A, that is 1s2 2s2 2p6. Option B, that is 1s2 2s2 2p6 3s1. It should have been 3s1. So 3s1. Option C, 1s2 2s2 2p5. And option D, so 1s2 2s2 2p3. So which one? Okay, option B. Yes, it should be option B. If I see the first one, this is nothing but 2p6 is there. It is nothing but neon, right? So when I am talking about this one, this is nothing but sodium. So it should be an halogen. Which is that halogen? It should be period number 2 means it should be fluorine. And what about this? This is nothing but nitrogen, right? So based on that we can tell that option B should be having lowest ionization energy, that is sodium, right? So option B should be the answer. Fine. So we will move to the next one. This was asked in AIPMT. Next question, whatever. This was JE. So the correct question number 15. The correct order of correct order of the decreasing ionic radii among the following isoelectronic species. Among the following isoelectronic species is, okay, so option A, calcium plus 2 greater than potassium plus greater than sulfide greater than chloride. Then option B, so chloride greater than sulfide minus 2, then calcium plus 2, then potassium plus 1. Then option C, sulfide greater than chloride greater than K plus greater than calcium 2 plus. Then option D, K plus greater than calcium plus 2 greater than Cl minus greater than S minus. So all of them, it is isoelectronic species. So option C, okay, option C, that means we are talking about this one. Naturally that should be the one, because more negative charged ion is on the left side, that is the highest ionic radii. Yes, all of you are absolutely right. What is the total number of electron in this isoelectronic species? What is that number of electron in this isoelectronic species? Anyone? What is that number of electron in this isoelectronic species? That is 18. Very good. So all of them, they are having 18 electrons. All of them, they are having 18 electrons. Fine. So therefore option C should be the answer. Okay. Anyway, already time is done. I will stop here. Any doubts in this? So if you observe, I have discussed around 15 questions. In that, if you observe, major part they have covered is related to isoelectronic species, then related to electronic configuration. So what I mean to tell you is, if you observe these particular questions, some of the questions, we can see they have focused on electronic configuration, right? So then you should know atomic number. There are some questions which will be based on the electronic configuration. So to write the electronic configuration, you should know the atomic number. That is one thing. Now, second one, when it comes to this one, they are asking about arrangement of the elements. So you should practice that. Okay. So then isoelectronic species, right? They have asked about isoelectronic species, and it has been asked by many times about isoelectronic species. Ionic radii, that is related to isoelectronic species. Ionic radii. Then ionization energy. We have the questions on ionization energy. Now my suggestion here is, you can read some of the competitive exam questions, or we have from learners only. This book is there. All of you might have got this book. You can practice from these books also. I have picked some of the questions from this book only. Okay? And always my suggestion here is, for one question, they will be giving options, right? So you prepare your own questions based on that particular question. You prepare more questions. Don't stick on to that one question only. You only prepare more questions on that particular question itself. Then try to solve that one. And each option, you should have the discussion. Each option. What can be the question if option A would have been the answer? What can be the question if option B would have been the answer? So what I mean to tell you is, whatever question is there, don't stick on to that. Okay, for question number 14, option C is the answer. Okay, fine, I have solved. So go to next question. No. each question you can only have the 3 to 4 sub questions by yourself. So that's how you should read the competitive exam books. Okay. So thank you very much and take care. Bye.